Hi everyone, I'm Aneesh, the founder of DevVoid. Today we'll be continuing with the DSA XAI series. So today we are planning on looking into the next problem in the series of NeetCode.io over here. The problem that we're going to focus on is valid parenthesis. This is a very interesting problem regarding stacks, and let's just dive right ahead into it, okay? So valid parenthesis is the problem name, and the problem statement goes like this. Given a string S containing just the characters, round brackets, flower brackets, and square brackets, determine if the input string is valid. Now they also mentioned what is valid. An input string is valid if open brackets must be closed by the same type of brackets. That is, round bracket open means you should close with round bracket on. Flower bracket open means you close with flower bracket on. And square bracket close means, again, flower bracket, square bracket, sorry. Second condition, open brackets must be closed in the correct order. Okay, we'll understand what that order means, but it should be closed in the correct order also matters. Finally, every closed bracket has a corresponding open bracket of the same type. Every closed bracket has a corresponding open bracket of the same type. Okay. Those are the conditions. These are the examples. We will discuss the examples more better in the whiteboard, but I just want you guys to take a quick look at the examples before we go deeper into it. Okay, maybe I'll just summarize it quickly here. Okay. So, sorry. Okay. We have round bracket open and round bracket close. So that's good to go. Open with one type, close with the same type. Okay, and in the correct order. You should not open first and then close. Right. Should not close first and then open. Open first and then closed. Makes sense. Proper it is. Second one is round bracket is opening, round bracket is closing. One done. Square bracket is opening, square bracket is closing. That's also done. Flower bracket is opening, flower bracket is closing. That's also done. So all of them are being opened and closed and also happening in the right order, and everything is good to go. That's also true because of that reason. In the third example, we are opening round bracket, but we are closing square bracket. That's not good. That's not the correct thing to close it by. So not the right order, not the right brackets. So false. In example 4, we have round bracket open, square bracket open. As soon as we open square bracket, we should close the square bracket first. That's what they're doing over there. So we are good to go on that side. Now what's remaining? The round bracket open that never got closed. Okay, they're closing that as well. That's why example 4 is also true. Okay. Finally, example 5. In example 5, we have round bracket open, square bracket open, round bracket close, square bracket close. This might seem fine from a open closing perspective, but it's not fine from order perspective. This is where order comes into picture. The order should be whatever is opened latest should be closed first. So if square bracket is open latest, that is, most recently, then it has to be square bracket closed first. Because they didn't do that, this is wrong and hence it is false. That's just a quick summary of what's happening here, but let's just quickly dive into this logic of it and what's happening exactly. Okay. So the input, let me just decrease the size of this. Okay. So the input, okay, is round brackets, square brackets, and flower brackets. The output is true or false. Now what's the logic that takes this input and gives this output? Okay. So there was a word that I mentioned, a specific word over here. What did I say? I said whatever bracket is present, most latest bracket when you encounter closing bracket, that's what you should look into. That is actually a very important observation here, and I'll tell you why soon. But yeah, there are technically multiple solutions you can do for this. Usually there's no I'm going direct, basically in simple, I'm going to directly explain the stack solution because I feel that's the most obvious solution for this one. But if you guys feel that you want to know about other solutions that are, time complexity wise, they're bad and stuff like that, we can take a look at that as well. But maybe we'd use AI for that, right? Again, the point is we are using AI with this course. So we'll use AI for understanding other solutions. But stack is probably a very simple solution anyways for this, and it's already the best solution. So we'll look more deeper into that. Okay. First of all, to understand this problem, you need to understand stacks. That is not the scope of this course, but just to quickly summarize what's happening. I will say, I'll explain stack. Okay. Stack essentially is, you can think of it as a data type that does the following. Okay. It follows the principle of, let's show examples before I explain the things. So let's take something like this, a small container. Okay. In that container, we'll put various pebbles, okay, that are quite big. So when you put the first pebble, let's call it as number 1. The pebble will go down, right, as 1. Second one will become 2. Third one will become 3, right, and so on. Now, when you remove it one by one, what's the thing that comes out? When you put it, it was 1 on the top, and then 2, and then 3, and then 4, and then 5. But removing it, what's the thing that's going to come out first? 5 is going to come out first, right? Or let's say, in our example, 3, whatever, right? 3 is going to come out first because that's at the top, right? So the one that we put in first, that is first in, is coming out at the end, so last out. So this is the principle that stacks follow: first in, last out. Okay, whatever comes in first goes out at the end. So first in, last out is what stacks follow, and literally a visual representation of it is like a box where you can put pebbles or whatever. You can put anything. That's why you stack things on top. When you stack things on top, you can't remove the bottom easily without disrupting the top, right? So usually what you do is you remove the top one by one by one by one. That's why it's called a stack, because you stack things right on top of each other and you remove them from top. Okay, that's why it is a stack, and it's a representation of, this visual representation is done in a code way. Okay. Now let's try to understand what's happening more precisely. Okay. So for this problem, let's take the brackets. Okay. Let's take the brackets with some examples. Okay. I get the round bracket opening, then I get the round bracket closing. Right after that, when I get a closing, I see that the previous one is the opening one, right? So we are good to go. Similarly, let's take this one. In here, I got the opening and then I get the closing. When I get the closing one, I see the previous one and I see, oh, okay, looks good to me. I go to this closing, then I see the previous one and I see, oh, okay, that also looks good to me. And again, when I go to this closing, I see the previous one and I say, oh, that also looks good to me. So here, what did we do? We verified that brackets are closed in the right manner, right? Good. What did we do? Every time we encountered a closing bracket, we checked what is the most latest one. In our case, the most latest one is the previous opening bracket. Okay. Similarly, now what we'll do is we will say, okay, we'll take this example. Here, okay, we have these two opening brackets. Then we get this closing bracket. Okay. When we encounter this closing bracket, we check the previous one. Or to be more precise, the most latest, very important, the most latest one. Okay. Which is this one. So we'll see, oh, okay, this is good to go. When you encounter this bracket, we need to skip the ones that we already checked, these two, and check the one that's most latest but not checked, right? So you get this. So every time we encounter a closing bracket, we check whether there's a opening bracket that is most latest and not checked. Two criteria: most latest and not checked. Okay. We can add a logic for this itself, which maybe we'll take a look into it a little bit later, but I want you to try to analyze a little bit more. Okay. But what did we do till now? We found whenever we reach a closing bracket, okay, find the most latest opening bracket that has never been checked. Okay, good to go. In such cases where everything is good to go, as you mentioned, as you can see in all three cases, we can return as true. Now, some cases we return false, also we don't understand, right? So we'll see that as well. We have something like this. So When you get the square bracket over here, you see the previous one, and that's not a closing bracket. But that's not an opening bracket of square type. That's very false. Similarly, we'll take one more example. This, and we have this one. Now, this is a very interesting example. You see, I do like this. Okay, when we encounter the first closing bracket, that is this one, check the most latest one, which is this. Good to go. Encounter this most latest one. Good to go. Encounter this most latest one, also round bracket. Good to go. Finally, we have done with checking everything, but you notice there's something remaining to be verified. In such cases as well, it is supposed to be false. Okay. If there's something that does not have a closing bracket, that's false, because they told physically that it should have an opening and closing bracket, right? So that's why this is wrong. Got it? So there's also one more case you have to understand and accept or think about. Okay. So more cases from what they have mentioned. Very important to understand that. So till now, what did we do? When you encounter a closing bracket, go to the most latest opening bracket. Okay. But if you notice some pattern here, which I want you guys to notice properly. Okay, let's take the last example that we took just now. Whatever is the latest from a stone perspective that we just mentioned, right? Whatever is the latest, let's say 3 is here and 2 is here, 1 and 0. Okay. The 3 goes in, right? Comes at the bottom. 2 comes next, 1 comes next, and 0 comes next. Okay. So see, whatever is the latest. Okay. Let's change this diagram to kind of represent our problem now. Okay. Before going to whatever is the latest part. Now let's say I use a stack. I take my own example. Okay. I take it as square bracket, round bracket, flower bracket, square bracket, flower bracket, round bracket. Okay. What do I do here? This square bracket goes in the stack. Okay. First, the stack becomes square bracket. Then the stack becomes square bracket, round bracket. Then it becomes square bracket, round bracket, flower bracket. Then it becomes square bracket, round bracket, flower bracket, square bracket. Okay. So we have 4 options at this point. That is, we did this one, then this is done, this is done, this is done, this is done. Now, if we want to check whether this is what is the latest square bracket, you see, if you notice something in our stack currently, whatever is at the top, which is what we can access directly, by the way, is what we need, right? You see, that's exactly what we're going to do. We're going to remove the thing at the top and check whether it matches the required bracket for this one. We removed it. Now, because we removed it, I'm just going to the side. It has become now. We removed and checked first. We removed it and checked and said, oh, well, they are the right brackets. So we are good to go. Okay. Next, we'll see square bracket, round bracket, flower bracket. We check this flower bracket with this one because we came here when we reached that point. And we say, oh, this is also good to go. And then we remove that. Okay. Now we'll go to the round bracket and check that as well. Is that what is needed over here? When we encounter this closing bracket? Yes, it is. That's good to go. Finally, after you traverse the whole string, you have only remaining is round bracket, square bracket. But we have something remaining that cannot be ever closed because a string is done. That's why it's false. But you see what our stack allows us to do with it. You see the power of it right now. I kept adding the items to the stack one by one. Then I just kept checking the top of the stack because top of the stack represents the most latest one. And the reason I delete it is because that's checked already. So I check something. If that's good to go, I remove it from the stack. So the next top item will be the next latest item. Got it? Remove that. Next top item will be the next latest item, and so on, and repeat. Okay? Very important to understand that. And that's how it's going to be. Okay? So now that we have this kind of understanding over here, hopefully what I've explained here, you get it. If not, again, we'll look into some more aspects of it. But first, let's write the code for it. Okay? So also, theoretically, if you're confident with the syntax and you understand the logic, you could use AI to write the code. Okay? But only if you're confident in the syntax and you can imagine and visualize the code for this, only then. So right now, I'm not going to use it for that reason because I don't want to promote that practice. But if logic is your main focus, which I want you guys to focus on over anything else, then it's fine. As long as you're confident with the syntax. Very important. If you're not familiar enough with the syntax, do not try to use AI to generate code. But otherwise, it's completely fine, and I would ask you guys to do it. We'll go back to the details of how to use AI for this again at the end of the YouTube video, because that's how we roll over here. But let's just quickly look into add panels program and see. Okay. So we'll just call an item called stack. Okay. A new variable called stack. Essentially speaking, it's just a list. Okay. I'll just comment it out and say here, just a list. Okay. A stack in Python can be done using just a list. That is just a normal list. So I use square bracket over there. Okay. Then what I do? I say for character in string, for every character in the string S, I say stack. Sorry, we have to do one more thing before that. We have to understand what is our closing brackets, and every closing bracket requires a specific opening bracket, right? So to represent that, we'll do a map. Okay, I'll just call it as bracket map. And the bracket map consists of when we reach a closing bracket is when we want to check the opening bracket, right? So closing bracket will be the key. That is, closing round bracket will give you opening round bracket. Closing flower bracket will give you opening flower bracket. Similarly, square bracket closing will give you opening square bracket. Okay. I don't like how it's formatted right now, but it's quickly formatted because it's kind of annoying me. Here you go. Okay. Okay. Finally, what we'll do is we'll just say if character is in the bracket map, that means it is a closing bracket. Otherwise, not a closing bracket. Okay. If character is in bracket map, it's a closing bracket. If it isn't, if else condition is true, then opening bracket it is. Okay. So in the else condition, we'll write first. If it's an opening bracket, what did we do in the visual representation? We just added it to the stack. That's done by using a list function called append, which keeps adding at the end. So that will be stack.append, and then we say character. Then we say if it's a closing bracket, let's get the required opening bracket. So required opening bracket is equal to bracket map of ch. Okay. And then I say what? Then I say if stack. So let's just say top is equal to stack.pop. Okay. If top is equal to stack.pop, and we say if top is equal to required opening bracket, then continue. Otherwise, return false. Because if it's not the required one, then we know at that point itself that is wrong. And finally, we just say if stack length of stack is equal to 0, then we say return. Otherwise, again return false. There are some cases here where we didn't handle, and we'll look into that one by one. For example, let's take the condition where the stack is not ready to be popped. Let's take the case over here. We find a closing bracket, but there never was an opening bracket. So the stack is empty at that point. So we try to remove something that is already empty. It will give an error at that point. So what we'll do is we'll just say if length of stack greater than 0, then you can continue that. Otherwise, or rather we'll say if length of stack is equal to 0, then we just say return false. Okay. Now we'll run this. See what happens. Okay. Submit this. Perfect, right? So we wrote the code for this over here. I did a lot of brackets and a lot of spaces and stuff, but it's actually very small. But let's just quickly deep dive into this quickly. So I'm just going to copy this, paste it here. I don't like the fact that it is structured that way. Okay. Okay, that's better. So you can see what this is the logic that we have currently. Okay. It's valid, blah, 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 whatnot, whatnot. So what's happening here? Let's take a smaller input and see one by one. Let's take this as the input and see what's happening. Okay. We take every character in S over here. So we'll take first item and does what? Is it part of the bracket map keys? Is it a closing bracket? No. So the first condition, if condition is false, so it goes to the else part. So the first one goes to the else part and says stack.append. So what happens to the list is, we'll just write a stack over here. It becomes contains the, I'm representing square bracket for the list, and I'll represent like this for the opening brackets. So this is the stack currently. Next item is closing bracket, and that time we'll check it is a closing bracket. So if condition is true over here, and if condition is true, then what do? You do find the required opening bracket, which in our case will use this map to give us this as the opening bracket. And then we'll check the stack to see whether the top item, which we just popped means our stack currently is empty, and we'll use this to check whether this is equal to this. Is it? Well, that is good. You can continue then. It's not final now. We can continue at this point. That means it is good to go. But it does not mean it's true answer at this point, because we didn't check the other remaining ones, right? That's why we didn't do true directly here. We just did continue. Got it? And then we check similarly do for this opening. It goes to stack, and stack becomes comprising of this opening bracket like this. Okay. Then closing bracket again. Not sure, my recording software had some issues, so it disconnected for me, but essentially we have bracket like this, and you can see how it goes, right? Opening bracket here, and then I go back and boom, we check again. So at this point, I'm done with checking all the string, and then we go down and see that, oh well, our stack is empty. If it's empty, it represents that we have checked for everything and we're good to go. Okay. So if stack is empty, it says true. Okay. Just a quick simulation of what's happening there. Ideally, this is not something I usually do, simulation of this, but we'll just take a look at it. Okay. So we'll just go back. Okay, right. Check the logic. Okay. We'll put in ChatGPT and see. Explain with examples. Okay. So what's happening? Let's see. Okay. So here we go. How it works. Stack is used to track unmatched opening brackets. Blah, 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 blah. I'd rather you guys look into what's happening here than me explain this, because like I said, the whole point of this is your exploration and my exploration together. So take a look at all of what's happening here. I'm just going to slowly scroll through all of this. Again, you can take a quick read and pause the video and look into this quickly at this point. So here you go. Okay. Okay. So that's a summary of what's happening. Along with that, can you give an alternate solution that is slower? Just to understand that there's another solution, I told you, right? Okay. There's actually multiple other solutions as well. But this is just another solution that is possible that's slower. But before we understand why it's slower, we need to understand how this is faster. So let's deep dive into this first before going to anything else. Okay. So what are we doing here? We have just one for loop. And what do we do? One pass of the whole thing. So what do we do? Square bracket, round bracket, square bracket, round, whatever. Right? Every bracket, opening, close, whatnot. But we check the string, which it is a string, by the way. This whole thing is a string. And we check every character just once. We go it, do some logic to it, do the next one, do the logic there, next one, logic there, next one, logic there, and so on. Just once. And each of them does not have multiple other checks that it has to do. Just one check, done. That is why this is O of n. Because every item in that string or input is gone through only once. But the input itself is varying. Okay. That is, the size of the input is equal to almost proportional to the time taken. That's why it's called order of n. Okay. So time taken is directly proportional to n, which is the size of the array or string. Okay. Finally, that's for time. For space, we are using something called stack, right? A new list. And theoretically, the stack could have the same size as that. If we only have opening brackets like this, it'll keep adding to the stack, right? So in this case, the stack size will also be equal to the input size. That's why we can also call this as O of n. Okay. So in our case, time taken is O of n and space taken is also O of n. If you stack time and space. Now, we can see in this example, what's happening here? In another solution, which is O of n square, by the way. Why is it n square? Let's understand that first. What are we doing here? We keep repeating, okay, and removing every pairwise values. So what we do is, let's take a string, right? And at every loop, we're going to remove the together pairs like this. So first iteration, it will become like this. Now it checks and sees, okay, doesn't look like it's same as previous, so we'll continue. And then it'll remove the square bracket next. So it'll become like this. Finally, remove the round bracket. It becomes an empty string. So if it becomes an empty string, right, we are good to go. That means it is a proper bracket, a proper system. Let's take an example where it's not proper. Let's take like this. Okay. In the first loop, it will become like this. This is flower bracket, by the way. And second loop, you see, there's no more changes possible. So it becomes the same as previous. Which means, well, these are same. So we stop here. And when we stopped, did we reach a point where it's null or empty string? No. That's why it's false. And that's the logic we're using there. Keep removing brackets that are close by together until you reach the end, where the previous removal and the new removal does not do any changes. In that case, if the string has empty size, it's good to go, otherwise not good to. That's essentially what this logic is. We don't need to understand this logic fully thoroughly, but it's good to keep in mind that there is a solution where we keep replacing the string in place. But it's not so good because time taken is n square. But space, on the other hand, is not extra space. So that is very interesting as well. But yeah, I mean, actually, sorry, I'm wrong. Space, we are using previous, so we are actually taking extra space. So my bad. It's O of n time complexity and O of n square space complexity. So it's worse in all cases, right? Because O of n square, because replacing a string implicitly is O of n. And we're accessing every item again once. Here becomes n into n. So O of n square. Every item is accessed once is O of n. And every item's processing side, we do again one more thing that's O of n. So O of n into O of n becomes O of n square. Okay. But I'm just showcasing that there's another solution like this that you can look into as well, but not recommended. Okay. So yeah. But I just want to showcase that there's alternatives to everything, right? Yeah, overall, again, these are easy sums. So I'm going to the depth of writing the code by myself and explain the code, everything. But as we go forward, I'll be only explaining the algorithm side, and the code will be written by ChatGPT based on our algorithm and stuff like that. Would not recommend it in competition stuff like that, but it is good to go when it's normal use cases. But yeah, that's overall stack problem explained in valid parenthesis. Hope you guys liked my concept and what's happening here. And yeah, catch you guys in the next episode then. Thanks everyone. Bye.